Hey everyone, so it's Hannah. I'm one of the LAs here, and I'm just gonna kind of walk through this activity. Sorry if the camera angles are a little weird. I'm using a different camera. I have two screens so I can write. So just kind of bear with me. You should be able to see my screen. So this is the activity from 2 weeks ago. I'm sending up a follow-up video because I know you guys, it's been a lot, Bio 120, and they extended a bunch of deadlines till today. So I really wanted to wait to give you this video just because as long as you showed up to class, you got the points. This isn't necessarily super graded activity. So we're gonna walk through it. So this is the DNA Yay. So this will be one of two videos. Second video will go through this past Friday. So this is the biomolecule review. So not everything I'll walk through in detail, but I kind of just want to walk you through some of how I process. So monomer, that just means breaking it down. What is the farthest you can break down a carbohydrate is to its mono piece, which is a monosaccharide. All that right? So that's the smallest. Once you start to build monosaccharides together, you get a polysaccharide. And then there's no bonds that you really need to worry about there. Next, we're starting with a phospholipid or a triglyceride. And that builds up into, the first thing I think of is that phospholipid, oh, my pen got bigger, phospholipid bilayer. So I'm going to put lipid, and lipids also are known as fats. So now that we're kind of in that wavelength of thinking about a lipid, a fat, a phospholipid, your monomer is actually going to be your fatty acid. So those I'll build up into triglycerides. Don't need to worry about a bond. Next, we have an amino acid. First thing I think of when I hear the word amino acid is protein. So our proteins, when it's completely broken down, are amino acids. When you start to build those up, you get a polypeptide, also known as a protein. Then that bond that links them together is that peptide bond. Now we know our phosphodiester bond. So phosphodiester should immediately make you think of DNA. Specifically, our nucleic acids broken down into their smallest pieces of nucleotides. And then our polymer, once you add them together, is our nucleic acids. So that's just a quick recap. If you have any questions, I'm going to tell you to look at your notes. Next is our weighted DNA. So the big thing with this is we, need to make sure your drawing is correct. So when I walked through this with my class, we first talked about polarity, we talked about your sugars, we talked about all those things. So when I'm drawing, the first thing I'm going to do is write out the sequence I know, which is a 3 as our start right here. And then C, C, A, G, G, T, A, C, T, and include a 5. Next thing I'm going to start with is just go across from that. So our C and G go together and our A's and T's. So we're just going to fill that in. And so our strands run anti-parallel. So if a 3 is up here, this is going to be a 5. This is going to be a 3. And then I'm going to start to fill this in based on what it says. So it says use circles and pentagons to show phosphates and sugars, and hexagon, pentagon shapes with the nitrogenous bases. So I just filled in all my bases. So then we need to remember that our C's and our T's get 1, and our G's get 2. That's our pyrimidine versus purines, which you should refer to your notes. That's an important fact to know through all of them. So I'm going to do these in red. So all my C's get 1. You do not have to color coordinate your drawing, but that's just who I am as a person. If you guys have ever met me. So now I got all my C's. Next, I'm going to do my T's. They'll be in orange, because I like to make things match. This would be a great time to kind of pause the video if you haven't, to walk through what I'm doing alongside me. Next, we'll do our G's. So they're going to get this, and then they get one little extra guy. Oh, I am not the best artist. I apologize to everyone who is a good artist that these are kind of atrocious. Just going to keep filling these in. And one more. We'll do purple for our A's. also get a little side piece. So next thing I'm going to do is draw in my hydrogen bonds. So my C's and my G's get 3 and my A's and T's get 2. So all my C's and G's, I'm going to give them 3. Back to those. C. So my dots are my hydrogen bonds. These get 2. Just dash lines. And next, then we are going to start to draw in our circles and pentagons to show phosphates. So personally, I always start on my 3 side. So when there's a 3, that means they get OH. They start with an OH. If they're not, they end with a phosphate. So your 5 end is always a phosphate. And that, gotta move over a little bit, is going to connect to all your line of phosphates. So I'm going to add my phosphates. And then we will use our sugars. So they always point to the 5 direction. So this is what your drawing should start to look like. And you'll just fill in the sugars on either side. So I will let you guys finish up the drawing. Professor Harrison's drawing should have been talked about by your LA. That's totally filled in. You can check out that video if you need to, but this is kind of the start. I just wanted to show you guys a quick drawing so you guys can start to see. So you would fill all this in, fill all this in to finish out your wonderful drawing. Next, we're going to talk about the replication fork because replication can be really scary because there's a lot happening. So the first thing you want to do whenever you're drawing a replication fork is just start with that simple fork structure. So I always draw it out. That was not my prettiest structure. Let me try that again. So this is what it's looking like. And then I will start to fill it in with everything that we have. So we'll use a second color, we'll use a blue. So both of these have some DNA being worked on. So this blue is our newly synthesized DNA. Black is our template strand, or our template, our old DNA. Then we're going to add a couple RNA primers. So this is just kind of that first part to setting up your drawing. Next, we're going to label our polarity. So that being said, it's going to be a 5 and 3. 3 and 5 because 5 always runs to 3. 5 always runs to 3, so this makes that a 5. Now we're going to start working through all the molecules we have. So we've started to label. Now we're going to do DNA helicase. So helicase breaks bonds and opens up the strand. So that is going to go at the mouth of our replication fork. So it's going to draw right here, helicase. Next on our list is DNA poly 3. So that adds nucleotides in the 5 to 3 direction. This is the workhorse. This is the powerhouse. So this is going to go right here. DNA poly 3. Choose our next color is our ligase. So ligase is our glue. It fills in the last phosphodiester bond. You're going to think fragments. those Ozaki fragments. So DNA ligase, we're gonna put right over here. So pretend there's a little gap in that blue and it's filling in that gap. Next is our primase, which lays RNA primer or synthesizes. Oh, I might have just spelled that wrong. So I made it blue. We already have a color blue. Let me switch that, sorry. For those who also appreciate coordination, let's make it green. Turn green, yep, okay. So our DNA poly 1 will be right in the middle of all of this. DNA poly 1. Oh, wait, we're doing primase. Might be primase. Sorry, guys. Back it up. There you go. Primase works by our helicase. I got ahead of myself. Primase. Now we're on DNA poly 1. We'll go dark green, DNA poly 1, and this, its job is to remove those primers, remove RNA primer, and replaces with DNA. So it's kind of one of the final steps. So it's going to be working in front of that ligase. There you go. So our new strand is being synthesized. So the replication fork is left to right. So it's splitting open that DNA. And so it's moving from this direction to this direction. Okay, last thing on this video is what's happening? This is a really important question. I want you all to be able to do this. I also think you need to be able to draw a replication for the test, so make sure you know what's going on there. But so it says helicase separates DNA strands by breaking the hydrogen bonds between base pairs. So next, our RNA primers need to be synthesized by made by primase. So once primase is in use, that means DNA poly 3 comes into play and creates a new strand of DNA using that old strand. So remember, template, leading versus lagging, using old strand as template. So you also want to note new strand is synthesized. Not great at spelling, sorry guys, I'm a science teacher, in 5 to 3 direction. So one of our last steps then, because we only have 5, is that DNA poly, now we're on poly 1, it's kind of weird that 3 comes before 1. DNA poly removes those RNA nucleotides that were laid, nucleotides with DNA, and finally, ligase finishes it out and rearranges the bond. Should note that ATP is used. Then you get a phosphodiester bond, links Ozaki. So guys, that is your quick recap of this Friday activity. If that's still not making sense, I really, really want you to talk to your LA and ask them all the questions that you have, or bring your questions to class on Monday. The professors know all about these activities and they're ready to help you. So once again, my name is Hannah. You can hit me up on Slack. And this is one of 2 videos, just quick explaining those LA activities for you. Good luck, everyone.